From Tuesday's lecture video, we show you different instruction about the multiplication and division. So you can use the mod and div for the unsigned integer multiplication division, or imod or idiv for the signed integer multiplication division. But that's only just for the instruction itself. So now we'll see how we'll combine those instructions together to do the calculation. So here, for example, I want to do the calculation is I have val4 equal to val1 and the sum of val1 and val2 multiplied by val3. So we just consider all those four operands, they are 32-bit. So of course you can see here, we know we need to do the val1 plus val2, right? So that's why we move the val1 equal to EAX. So we can add the val2. So after we add EAX, right? So did you remember, since we have the EAX for the sum, so if we want to do the multiplication, we can right away using the, if we are considered as unsigned integer, we can just direct to using the value from EAX to do the multiplication. So one thing is sometimes after we do the multiplication, right? So we will consider after the multiply, the EAX should be holding the value. But you do know after you do the multiplication, after the mod calculation, supposedly they will have the product equal to combine at the EAX and the EDX, right? So that's why. But here, if we consider the val4 is only one 32-bit operand, so that's why if we only have the EAX value, then wonderful, we can just direct to assign the EAX value to val4. But this situation is only for what? Only for the EDX value we can ignore. So that's why what kind of situation after the mod operation you can ignore the EDX. Right, the carry flag is clear. So that's why here you will have the conditional jump when the carry flag is set. Then we just jump to somewhere, say the value is too big. Otherwise, you can see the EAX just moved to the val4. We got the value. So this one actually is considered all your operands, they are 32-bit. So that's why you don't really can combine your product from the EDX or EAX. Unless now here your product at the end, if they have either an array of the 32-bit or have some other way they can do the calculation to save the value correctly. But this one is for the unsigned integer. For the unsigned calculation situation, no matter is your mod or div, they are considered only the carry flag. But if they are the signed integer to work on the imod or idiv, so then we need to consider the overflow flag. So that's why we see this example, we just consider they are a signed integer. So this one will be different. Actually, we will do the product of val1 and val2, then add val3. So can we have our result actually in EAX? So right, so the first thing we have the val1 equal to the EAX, assigned to EAX. So we just do the net. So then because we consider a signed integer, so that's why we do the imod. So after you multiply val2, right? So this one, because you have two 32-bit operands to do the multiplication, so possibly they may not fit into the 32-bit operand. So that's why, because this one is the signed integer, so we need to check the overflow flag. If the overflow flag is set, we just jump to that's too big. So that's why I cannot assign to EAX. Otherwise, you just do this one. So you add EAX with the val 3. However, again, before we just do the addition, right? We didn't do any check. But from now on, since you know, sometimes you may have the value is too big. So that's why, again, you need to using the carry flag to see if they are too big or not. Otherwise, if they are not too big, right, then your EAX is holding the correct value. So here I just using one unsigned integer and one signed integer to show you how they really work on the combined arithmetic expression. So of course they have more example here. So that's I just want you to see to read by yourself to see how you understand how they will do. And also when they here actually we can do the modulus as well. Okay, so when you do the imod or actually idiff, so that's why we need to do the sign extension. So just check for those operation or the conditional jump. Do you have any question on that or not? So then we can talk about it during the Zoom meeting on Thursday.